So what we'll do now, we are going to store the username in another variable and password in another variable. For that, I will create another variable here, constant credentials, and use json.string if json.pass. And pass the response here, and const username equal to creates dot its capital username, and constant password equal to credentials dot password. If you don't know why I just pass this response as a JSON, because this value is totally available in the string. So this is a string format. This is a secret string. The name suggests us. So we need to pass it as a JSON so that we can retrieve the value from the username and the password separately in different variables. Okay. So now we are going to log the console.log username here, and we are also going to log console.log password. Let's check it now. So deploy. Before going to get a logs, I will delete this log. Okay. Now just click on test. What will happen? We not provide any secret string here. We directly pass on the entire response into the json.pass. So that is the reason it will not get converted. So we need to provide a secret string. In that secret string object, the username and password is available. So the response dot secret string. Now we again deployed it. So there might be one log here, which is a 1644. Now let's test it. Cancel. Test. We are not going to save it. We are going to invoke it directly. Okay, now it's invoked without any type of error. So let's check our logs here. It's a 1446. If you just open that log, now we get a password. Username is a Redis and a password is a 1234. I want to show you one more thing about the Lambda, because whenever there is any error for the Lambda, it will go into invoke also, and it will store the error in our CloudWatch logs. So you can debug from here also. Now we are ready with our username and password also. Now what we want to do, we want to generate a random password. We keep a username as it is. There is no need to generate a random username. So what will you do? If you want, you can generate a random username also. There will be no issue. But for now, I will generate a one random password. So how you can generate a random password? You can implement your own logic for creation of a random password. But for that, actually, Secret Manager SDK already provides us one logic for creation of a random password. So let me just show you that function also. Get random password command. It generates a random password. We recommend that you specify the maximum length and include every character type that the system you are generating a password for can support. So if we click on get random password, this is the basic syntax for creation of the random password. We can define your password length also. We can exclude some characters. We can exclude numbers, punctuations, If you want to exclude, we can exclude it, exclude uppercase, lowercase, include space, and require each included type. We can define the types here. In our case, we are going to exclude some characters. So what characters we are going to exclude? Let me show you here. Okay. Instead of going to the GitHub, I will show you in the Lambda function itself. Because why we want to exclude some characters? Because in the updation of the Redis, there might be an error, and we cannot update the Redis because of the special characters available in the password. So we are going to exclude characters like this: backslash, forward slash, dollar, hash, exclamation mark, and this is nothing but our space. Okay, so let me just copy it. And I will paste it in I paste it here directly. So we are going to exclude some characters so that there will be no any error while updation of the Redis. So let's get back, and now we are going to generate. Now we are going to generate a random password. Before going to generate a random password, we need a permissions to generate a random password. So where we can define the permissions? Yes, we can define the permissions in the role of our Lambda function. So where we can find the role, just click on configuration. Here we can, in the permissions, we can find here a role. Click on role name. Click on policies now. Because we already attached that policy, we search here by Roshan, which is a Lambda function version 2. And we are going to edit that policy. Now which permission we want now? We want the permissions for the secret manager, and what we need to generate a random password. So get random password, it's the permissions. So we added that permission for that particular secret manager only. Click on next and click on save changes. Now our policies get updated. If you just see the role or the permissions attached to a role, so this is the permissions attached to a load. One is for our basic CloudWatch logs, and second one is we created earlier. Now it have three types of permissions. First one is to get secret value. We already execute that. Now what we are going to do? We are going to generate a password, and after generating the password, we are going to update the secret. So let's get started. Again back to the Lambda function. Now we are going to import that package so that we can create a random password. I just copy paste it here. Okay, it's already declared here. So we specify only a get random password command. So can we do that? Let's check it. Can we define multiple packages? Maybe we can define. Okay, now this block of code for creating the secret, for fetching the secret, I will write down here: to get credentials from secret. And next block of code, to generate the password, to generate a password only, right? We are not going to update the username. But if you want, you can update the username also, depend upon you. So again, I will change this client here. So this client is for the get secret. So we can define here get secret. It is for the get input. Again, command is for the get command. Why I need to change it? Because there is a same variables available. Okay, no issue. I will define a get yes as, so that I will get to know it's for the secret. Response is for the get as response. I will just copy it, paste it everywhere. So username and password, it's the same. Gets command, it's a gets command or it's a get s command? Yes, it's a get s command. So now let's check it again if all things are okay or not. Delete the logs so that we can get a fresh log here. Test it, invoke it. See, this requires 3 seconds. So let's check the logs now. Okay, it generated log here. If we open log, yes, we got a Redis and a password as a admin1234. Okay, everything is okay right now. It's a SM for Redis. Okay, let's back to the code. Now we are going to generate the password. So what is the code for generating the password? So we need to import a secret manager client. So let me show you. Okay, this client is already imported here, so there is no need to import a client again and again. Okay, we're going to use that client here. I just copied and pasted above the to get a secret from secret comment. And now we are going to generate the password. If I want, I can implement asynchronous function logic here as same as we defined in the Node.js, and we can wrap it by using a try catch block. As I just checked my previous Lambda function, but I think this is not required in Lambda function, because the Lambda itself manages its own log. So there is no need to use a try catch block, right? So I will not going to use any type of function or define any function here. We are going to write a code as it is. So there is no need. Now to generate a password, we need to create a client. We have a client. Now we have client. Now we are going to just copy paste it the entire content. Okay, we are not going to use that content. I will just copy paste the previous content. It's for the random input. It is also random input. Command is also random command. Okay. This block of code is to get a credentials. This block of code is to generate a random password. Let me open my previous Lambda function so that we can copy paste the entire content for creating the secret. So as I told you, I created here one asynchronous function. I check if the username is equal to the same username. So if I want, I can implement this logic, but there is no need to check the username, because in future, what if we want to change the username also. So this Lambda function is not going to execute at any cost. So where is that content? We are going to copy this and paste it there directly. If you notice, there is no need to provide the secret manager ARN, by the way, for creating the random password, but there is a need to assign the permissions. Let me correct the indentation here. Get random password, and I will going to use a console.log random password, random response. For now, we are not going to console log username and password. We are going to use console.log a random generated password. So let's check it now. Deploy. Is there any CloudWatch? It's 1656 CloudWatch available only. Test and invoke. We got the error message, asset denied acceptation. Okay, let's check it. User ARN is not authorized to get a secret random password. I know that error. I will show you what happened. Instead of giving the permissions to the same statement, we need to create another separate statement. I will show you here. I got the same error in my previous Lambda function also. So this is the we will use the same statement, and in our previous Lambda function, if you check, define another statement. So where is the, yes, this is the another statement. I don't know why this is happening, but in this is regarding get random password. The value is related to the secret manager only. So we need to define the another statement here. So let's correct it again. So where is by Roshan? It's a rotation 3. Click on edit. So we are not going to use this secret again. We need to define another statement here. So we need to define add new statement. Statement is for the secret manager and random password. We need to define resources. See here, this is available for all resources. Next, and save changes. Now if you check the role again, get random password is also added to our actions. Now let's invoke the Lambda function again. 1713. Test and invoke. Function logs. Yes, it's a SM Redis. If we check, it gives directly the random password here. And if we check a CloudWatch, here we also get one random password. We invoke it or we just, okay, let's check it again. Okay, no issue. It will give a random password here. Every time it gives a random value here. Now let's try to deploy it again with username and password also, and try to test it out. So we get a random password here, and if we check over CloudWatch logs, 17.7, it's showing the admin and it's showing the username and password. And we get a random password here also. But for accessing the random password, we again need to define this random password, so that we can extract the object of a random password. So again, const dot, not a const dot, new password equal to random response dot random password. So let's check it now. Because we don't want metadata, right? So we need only the random password here. Okay, it's executed successfully. Let's check the logs here. 1718. We got username, password, and let's check for the random password. We got random password or not? Did we console log? Okay, we did not specify the console log here. So again, console.log new underscore password. Deploy it. I will clear all the logs. Okay, now test it. Now let's check the logs here. 1719. Yes, we got a username, password, and a random generated password here. Now what we want to do? We get username also, we get a password also, we get a new password also. Now we want to update the secret manager. So how we can update the secret manager? So let's start it to implement the secret manager. It's for to get a random password, and next block of code is for to update the secret manager. I'll give it as a name, secret manager. To update the secrets, if you remember, we store the secrets username and a password. So we need to update both the secret username and password also. Whenever there is a rotation, we cannot update only the password itself. But in this scenario, I will specify the username as it is, which is nothing but our Redis. And for the password, I will pass on this password value. So let's get back to our AWS SDK. Search for the update secret. This is nothing but update secret command. Any other command, update secret version stage, we don't want any stage. Update secret command. Update secret stage is for the handling the secret stage manually. This is the basic syntax. We need to provide a secret ID, nothing but the ARN. And we need to define the secret string, which is a string value. Okay, let me cross check it again. Secret string. The text data to encrypt and store in the new versions of the secret. We recommended to use JSON structure of a key value pairs for your secret value. Okay, let's get started. To update this secret, what we need? Again, we need a client. We already have a client. We need an input here, constant input, and we need here a update secret command also. There might be some changes in the syntax. I don't remember it actually. Let's check it. Now constant client, constant input. We are going to specify the input. Input is for updation of the secret. So I will give here a const update input. It takes some values. First value required, in our case, it's a secret ID. Secret ID is nothing but our ARN. So I will just copy paste it. Second, what we need, we don't need any type of this client request token, descriptions, KMS key ID, because all the values will be the same for our secret binary. Let's check it. What is the secret binary here? The binary data to encrypt and store in the new versions of the secret. Okay, we recommend that you store your binary data in a file and then pass the contents of the file as a parameter. Okay, I didn't understand. No issue. I will just going to use the secret string here. Secret string and string value. The text data to encrypt and store in the new versions of the secret. We recommend you to use a JSON structure of key value pairs of your secret value. Either a secret binary or a secret string must have a value, but not both. This will contain sensitive information, so the services does not include it in the cloud trial log entries. If you create your own log entries, you must also avoid logging information in this field. Okay, so let's check it now. What will be happen? Secret string. We need to define the string here. So how we can define the string for the username and a password? We need to use a JSON structure of key value pairs. So should I need to use quotation marks here or not? Username like this. User will be the Redis, and for the password, it's a capital P or small p. It's a capital P. And what is the password? Where is the generated password we stored? Which stored a generated password in the new password. New _ password. So we need to execute this update input. Simply copied it and paste it. Again, this is for the input. Sorry, not input. It's for the update _ command. The response is update _ response, update _ input, and update _ So let's console log the response also. So we'll get to know update _ response. What will happen? CloudWatch logs, we have CloudWatch logs till 1790. Deployed it, test it. Okay, I know there is an error. Error type serialization error, startup or map found were not accepted. Okay, actually the error is not in the syntax, because if you remember, we update the password. The password get updated in the plain text. So that is the main reason this not get updated as a key value. Then what I did, I just delete that entire secret from that secret manager, and I created new secret and update my policies with this ARN. Now if I showed you, let me just show you here. I passed the JSON.stringify username as a Redis, and password is as a my new password which I generated here. If I just click on deploy, before going to retrieve the password, let me just show you the current password, which is this one, which is a random password. Now we are going to test it now. Yes, if I just again retrieve the password, Now the password is changed. So this is the way how we can update the password in the secret manager. Now in next video, what we are going to do? In next video, what we are going to do? We are going to launch our Redis, and from EC2 we are going to create one Node.js application which help to retrieve the value from this Redis, as well as update the or manage the password in the Redis. Okay. In previous video, we just saw how we can configure the Lambda function to create the password and to update the secret manager for the Redis. Now we are ready with our RDS proxy and AWS secret for the RDS. And we also created one Lambda function. In that Lambda function, we created a random password, and this random password get updated to the AWS secret manager whenever this AWS secret manager invoke the Lambda function. Now we are going to configure the Redis and we are going to use a library here for making the connection pool. It's not actually IO to library, it's IO Redis. It's IO Redis. Okay, before going to configure for the Redis, let me just explain you about the Redis beyond just a configuration. If you know, Redis is a single-threaded architecture, or it follows the single-threaded architecture. So what does it mean by single-threaded architecture? Which means that it executes the one command at a time. So just like RDS, there is it will be accept multiple commands at the same time. There is no any concurrent execution of the processes in the Redis. So which is nothing but a single-threaded architecture. So in Redis, why there is a single-threaded architecture is followed? Because the most of the task in the Redis is related to a memory consumption as compared to the CPU consumption. So one core CPU is more than enough for the Redis, according to the Redis team. And so to enhance the speed or we can say to the speed of retrieving the data from RAM, or we can say a memory, they only use a single-threaded architecture. Because if you use a single-threaded architecture, there is less thread synchronization. There is no need to manage the thread synchronization, and there is no race condition for the CPU. So this is the main reason to increase the speed of retrieving the data from the memory, and to minimize the CPU utilizations, and to overcome a scenario where race conditions. It follows the single-threaded architecture. So if you remember, we also discussed the internal architecture in AWS for the Redis. It's just like a RDS. There is nothing difference between Redis architecture, cluster mode, and RDS multi-AZ. So this is the diagram which we discussed earlier also. It's a cluster mode disable. If it's a cluster mode disable, it contains one writer node and reader node, or we can say a replica node. If it's a cluster mode enable, it contains a multiple shards. So these shards is nothing but the group of nodes which contains a writer node and a reader node. So like this, we can create n number of shards. It's depending upon the type of engine which we selected. So Redis is a single-threaded actually. So whenever we configure the Redis, there is no any option for selecting the CPU, just like RDS or EC2. Let me show you that. If you go to the Redis Elastic Cache, I will explain how we can configure this, but I want to show you that option only. Design your own cache. We are going to set a cluster cache, cluster mode enable. If you just scroll down here, there will be only option for selecting the memory, which is nothing but the RAM of our, we can say, a server. There is no any option for selecting the vCPU or eCPU, any type of CPU. There is not any option because it's already selected, and which is a single threaded, which means it have only one core of CPU. So this is the main reason why it is a single threaded. So let's back to our diagram. Now before going to configure the Redis, we will again back to the Lambda function. In that Lambda function, what we do, we already know how we can generate the password and how to update the secret manager. Now what we'll do, the generated random password, we will update it to the Redis or the Redis user. So for a Redis, for creating a user, there is a explicit option in the AWS, which is a user management. So we need to create a user for the for our Redis in user management, and we need to add that user to a user group management. And this user group management can be added to a Redis OSS while configuration. So this is the main flow of adding the user. And one more thing about the Redis, the connection is encrypted only if there is a user available. If we apply user or added user to a Redis, then only the connection is encrypted. I will also show you that option. Okay. For now, we will going to create a one user, and this user is added to a user group management, and user group this user group particular can be added to a Redis OSS. In user group management, I already created one user group here for rotation. There is only one number of only one user. Let me show you. If you go to the user management, this is the default for rotation, which I created earlier. So this user is only added to the user group management. This is a default user. We need to add another user also. So just click on create user, user ID and username. If you want to give the user ID and username same, then there will be no issue. I will just give a user ID as a Redis, and then my username is also Redis. If you want to change it, you can change it. Then why it is our user ID and username will be same. Okay, let me show you that also. Because when we created our secret manager, we already defined their username and password. That username and password is the same username which can be added to the elastic cache. So this is our secret which we created for the Redis. Return secret value. So here is a username Redis and password. So according to our diagram, what we want to do, we want to store the username and password to the Redis. So in our case, we are not going to use the username to store in the Redis. We are only storing the password. Now, so that is the reason user ID is a Redis, and user authentication, of course, it is not IAM authentication. We are not going to create any tokens. We are going to use a password. So what is the password? I will type my password here. For now, I will type a random password. If you want, you can copy paste the secret manager value. So what is the access string? Okay, let me show you. You can say it as the access string is nothing but the role-based access control. It's just like RDS. If you know any commands related to the database, we can restrict our users from accessing our database. So just like that, there is access strings provided by the Redis. So we can apply these access strings to our specific user. By default, when I created this default user, I turn off all access for that user. And for the user which we are going to create now, I will access all the access strings. I will assign the permissions for all access strings. So just click on create user. User ID is Redis. It's a password. Okay, access string. If you want to know more about the access strings, just go to the documentation, you will get to know. So this is a separate for actually for the user, and this is the separate for actually for the commands. Click on create. Now a user is get created. Now we need to assign that user to our user group management. So for rotation, just click on that, modify, manage. This is the second user which are going to add to our user group manage. So it will be in a modifying state. Now let's back to our Lambda function. What we want to do. I will open another tab here. If you remember, we created functions inside the Lambda. Sorry, we created snippets of the code inside the Lambda based on Node.js. So this is my Lambda function. Till our previous video, what we have just done, we just created one random password and we updated that random password to a secret manager. But there is no any updation in the Redis side. So now what we are going to do, we are going to update the same password to the Redis user, so that by using this easy to application with Node.js, we can access that username and password. So which username and password we are going to access at that time? We are going to retrieve the username and password from the AWS secret. So there is no need to mention the username and password while accessing the Redis directly. So this is our Lambda function. We generate a password successfully. We update the secret manager and we retrieve the secret value. What I just did, this block of code, I will just cut and paste it here. Because whenever the Lambda is get invoked, it will first generate the password, then update the secret manager, and then same username and password will be get stored into our elastic cache. Just note down here, we are getting a value from the secret manager. We are not going to get a value directly from the password. So this is not the best practice to get the password directly from the random password generated function. First of all, we need to store it on a secret manager, and after successfully storing to a secret manager, we can retrieve that value from the secret manager. So this is our block of code which retrieve the value from our secret manager. We are going to use only the password for storing the password to our elastic cache. So same thing, what we want to do now, we want to update the elastic cache. So let's first confirm our user group is activated. Yes, it shows the active state. It's container 2 users. Default for rotation and the Redis. User ID is Redis also, and here is also in AWS secret our username is a Redis and a password. Now we want to update the elastic cache user. So how we can update? For that we need AWS SDK. I will be using a JavaScript or the Node.js. If you just scroll down, I will search it here for the cache. So here is the option for the elastic cache. So what we want to do now, we want to modify the user. So search here modify user. So here is the modify user command. SDK is not that much complicated to implement. So same thing, we are going to import one module here. I already imported here. Now what we want to do, we want to create one client for the new elastic cache client. So let's back to our code. Okay, so this is our code. It's for the to update elastic cache. Now what we want to do, we want to create a one client. Okay, it's not copied actually. Let me copy it. It's a client for over the elastic cache. Simply paste it here. So there is no need to mention the config or the credentials because AWS Lambda is already available in our AWS Lambda can communicate to our another AWS services. Client is related to the elastic cache. So I will give it here a cache client. So now what we want to do, we want to execute a command. So constant input. It will accept some arguments. So what will be the accept? It accept a user ID, which is a compulsory, or we can say a require. So this is a user ID. So what is the user ID? If you want, you can retrieve the user ID here also. There will be no issue. But I will just hard code here user ID. So what is the user ID? It's a Redis. Where is it? Okay, let me show you. If you go to our users, so this is our user management. In that, this is our Redis, or the user, and user ID is Redis. Username is also Redis. So this is our user ID. And what we want to do with user ID, we want to update the password. So we need to define the passwords here. So passwords. Okay. Passwords. So we are going to use that variable password. This password is get retrieved from the secret manager. I'm not going to store this password directly from random password, or the from after generating of the random password directly. First of all, I just update to the secret manager. Then I retrieve the value from that secret manager, particular that password, and update that password with our, and try to update that password to our elastic cache. So what will be the next command? So these are all the optional parameters. There will be no need to assign these parameters. So just like other implementations or other implementation of SDKs, constant, it's a cache. I will type it as a cache underscore input. Let me copy it. So here is the cache underscore input. Here is the cache underscore command. So there is no need to hold that in a variable. Okay, so this is only the block of code which are going to use for updating the password in the elastic cache. Let me explain again what we will do here. This block of code is to generate a random password for the secret manager. This block of code to update the secret manager, because once the random password is get generated, we need to update that password to our secret manager. Okay. Once the block of code is generated, once the password is generated, this password must be stored in the secret manager. So this is nothing but this block of code will do to update the secret manager, so that in future, if these EC2 applications want to retrieve the data, it will retrieve the value of username and password from the AWS secret, and will access the data from the Redis. In next, what we will do? In next step, we mention a block of code which will be going to retrieve the value from the AWS secret, and we hold the password from that block of code and try to update the elastic cache with that password only. If you get maybe you get the flow of our code, because in case of RDS there is no need to mention such Lambda function, because RDS will take care of it internally for rotating the secret and updation the password in the RDS itself. But in case of Redis, we need to take care of rotation of the secret also and updation of the same secret in the Redis also. So that's the reason we need to define the code which going to generate one random password. This random password will store in the AWS secret, and the same random password by using Lambda function will be get stored in the Redis. So this is the general flow. Okay. Now before going to rotate over secret, we need to assign a permission for the elastic cache. If you remember, we assigned the permissions for only for updating the secrets in the secret manager. We did not mention any type of permissions related to the elastic cache. So again, for that, we need to assign the permissions to a role of our Lambda function. Click on configuration. This is a particular role. If you didn't know any about the role also, then please YouTube it or Google it. Then you will get to know what is the role and what is the importance of role for any service. So here are the two permissions which we created. One is for the storing the logs in the CloudWatch. Second one is created by us. forget secret value from the secret manager, update the secret and get a random password. We click on edit. I just click on edit. Okay. So we are going to create another statement here. Just enter and add new statement. So what is the statement? The statement is related to the cache, or we can say a elastic cache. So I will select the service here. What actions we want to perform? We want to modify the user. Okay, so here is the modify user, and what type of resource we want to assign this permission, or the permission is applicable for. It's applicable for the particular user, and that ARN of that particular user can be found here. Let me show you. So this is our users and this is our ARN, which is particular for that user only. So the Lambda function is can rotate the secret or update the secret for that particular user only. Select it and paste it. Add resources. So the resource is added successfully. Click on next and click on save changes. Okay, now our policies get successfully updated. So let's cross check it. Okay. Yes, so this is our statement 3, which is allowed for the modify user for the specific ARN. Now we are done with our role also for the Lambda function. Now we are going to test it. So how we can test it? For testing of this Lambda function, we need to rotate the secret. So as we see in my previous video, how we can rotate the secret, just go to the secret manager, rotation, click on edit rotation and click on save. Then secret will be get rotated automatically. So I will just tell you one more thing here. I'm not going to configure the Redis here. First of all, I will show you how the user will be how the password of the user get changes. Then we are going to configure the Redis. Once the password is get rotated, the status of this user will be get changes from active to a modifying. Click on save. Now our Lambda function is get triggered. Let's cross check it. Okay, now it's showing the status of modifying, which means that this Lambda functions successfully updating the password for that particular Redis and that username. And one more thing, whenever there is a rotation of the secret for our Redis, there might be a downtime, because as you can see, the password is get rotated. So try to modify the password in the maintenance window. I tried using the our secrets staging labels also for assessing these Redis by using AWS previous label, and try to assess the Redis by using the previous password. But it is not allowed for assessing the Redis with a previous password if our user status is in a modifying state. We can only assess the Redis with a particular user with AWS current password only. Okay, and the time required for modifying this user is for the 1 minute and 16 seconds near about. So that is the time required for modifying the user. It's actually 1 minute and 16 seconds approximately. If you want, you can start a stopwatch for it. Okay, now we are ready with our fully functional Lambda function, which will help to rotate the secret in Elastic Cache also and AWS secret also. Now what we are going to do, we are going to launch one Elastic Cache by using the Redis OSS cache. So before going to launch Redis, I will explain few more things about the Redis. It's about actually the endpoint. As we discussed in our previous video, there are two types of configuration or the architecture we can do in Elastic Cache. First is a cluster mode disable and second is a cluster mode enable. In cluster mode disable, there is only one shard or we can say a node group which contain a writer node and a reader node. In cluster mode enable, we can create a n number of shards depending upon the selected engine. So what happens if we select a cluster mode disabled? We can create, there will be two types of endpoint. One is for the configuration endpoint and second one is a reader endpoint. This configuration endpoint will point toward the writer node and this reader endpoint will point toward all the reader instances or a reader node. And if it's a cluster mode enabled, as there is a multiple number of shards, the configuration endpoint will take care internally for the writer node also and the reader node also. So there are actually three types of endpoints available for the Redis: configuration endpoint, reader endpoint, and it's actually a node level endpoint. So let me just draw diagram here. It's actually a cluster mode disabled, and it's a cluster mode enabled because we can create a n number of shards. Okay, and it contains reader node and a writer node. Okay, so the configuration endpoint will point toward the writer node and this reader endpoint will point toward the reader node. And in the cluster mode enable, it will internally take care of pointing toward the reader node and also a writer node. So this is about the endpoint. But as we see in the RDS, if we select a multi-AZ, it will give us two type of endpoint. Just like cluster mode disable here, configuration endpoint and a reader endpoint. If we select a single AZ, then it will give a single endpoint. And one more thing about the Redis is related to the scaling only. If you want to scaling or scale out in cluster mode disabled, we can only scale in vertically, which means that we can change our engine version in a cluster mode disable. So suppose if we selected 2 GB of RAM, then we can select or we can create a second node by using a 4 GB of RAM. But internally what Redis will do, it will create another node. It will internally create another cluster mode disable architecture. It will copy the data from previous one to a new one and then delete the previous one. Internally it is carried out by the AWS. In cluster mode enable, we can do horizontal scaling also and vertical scaling also, which means that we can add number of shards also, we can add number of replicas in that shard also, and we can also we can also update the engine version. We can also update the instance type of our Redis. So this is about the scaling in Redis. Now let's back to the console of the Redis. We are going to launch one Redis here. So just click on create Redis. It's not a serverless. We are going to select a design cluster. Creation method is not a easy method. It's not a restore from backup. It's a cluster caching. Okay, one more thing about the restore from backup I want to tell you. Actually in AWS documentation, what they said, there are two type of mode, offline mode and online mode for scaling. Offline mode is nothing but taking or the scaling of cluster by using the backup, which means that we can promote the backup to a standalone cluster for the Redis. And the online mode is nothing but modifying the existing cluster. So this is nothing but the two types of modes which is they mentioned in the AWS documentation. So we are going to select a cluster cache here. Cluster mode enable, yes. So that if we select a cluster mode enable, how many endpoints we get? We get only one endpoint, configuration endpoint. And in RDS, what will happen if we select a multi-Z? It will use a two type of endpoints, configuration endpoint and a reader endpoint. Might be confusing, but if you just concentrate, you will get to know. Now here a cluster name, it's for the Redis, for RDS. There is no any description. Location, it's actually multi-agent. Parameter group, just like RDS, we can define parameter groups. If there is any value related to the parameter group which you want to modify, we can modify that value here in the parameter group. Port is a by default port which we are going to use 6379. In the node type, we are going to select less memory. See, there is not any option for selecting the CPU because it is single threaded. Number of shards. So what is shards? So this is shard 1, shard 2, shard 3. So if you select a number of shards 3, it will create us 3 shards with 2 RAID replicas. So this is replica 1, replica 2, replica 1, replica 2, replica 1, replica 2. Okay. Then how many endpoints if available in that configuration cluster mode enabled? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 endpoints will be available. So there is no need to manage that number of endpoints. We are going to only use the configuration endpoint. Subnet group settings, there is no need to change the subnet group settings. Availability zone placement, slot and key spaces, which means if you want to distribute the slots and key spaces, we can distribute it. Availability zone placements, we can define the preference for the slots and key spaces. Click on next. Encryption at rest, yes, we want encryption. Encryption in transit. As we mentioned earlier, if we enable encryption and transit, then only we can assign the user to that particular Redis. If we didn't mention encryption in transit, there is not any option for adding the user to our Redis in AWS console. So we need to enable encryption in transit, which is nothing but the TLS. So we are going to select the access control method here. We are going to use user group access control list. If you remember, we created one user group management. In that user group management, there is two users. One is a default user and one is our Redis user. So we are going to select that user group, which is nothing but for rotation. In that user group, 2 users is available from here, and these 2 users now get attached to our Redis. So this is the flow how we can configure the user for our Redis. Security group, as we discussed in our previous video, security groups, we are going to use the for Redis, which allowed only the EC2 application traffic. Backup, if you want to backup, we can select a backup just like RDS. We can define a backup window also here, and we can define a maintenance window also here. And this is about the auto upgrade minor version. If you uncheck it, then we need to manually update our minor versions. Minor version is nothing like 7.6.2, 7.6.3. So if we enable it, it will get automatically updated. It will get updated in the maintenance window, by the way. If you want to send any type of notifications, you can use SNS, which is a simple notification, another type of service. If you want to export the logs, you can export the logs just like RDS in the CloudWatch. But for now, we are not going to export any type of logs. There is no any type of tags. We can cross-check our information. Okay, let me just cross-check the security group, which is the important thing. Okay, security group. Just click on create. Now our Redis will be get created. Okay, now our Redis is get successfully created. Now what we are going to do, we are launch our same EC2 applications and try to store the data in Redis, and then we are try to fetch the data from Redis. So let's get started here. So let me open my new tab, EC2 console. Okay, it's a EC2. If you know, I already launched one EC2 instance. In that EC2 instance, we have snippets of code for the RDS, for retrieving the secret manager, for backup logic with jitter. All things are available. We just need to pass the parameters. meanwhile, I will explain the type of library which we are going to use for accessing the elastic cache. So there is a one library which is called Redis. If you are using Node.js or aware about the Redis, so this is the library we are going to use. If you just go through the whole documentation or just this page, there is no need to read all the documentation for the Redis. You will get to know how we can connect to the type of clusters or different types of endpoints by using this Redis library. So we just configured the cluster, so we are going to connect by using the cluster. So just like MySQL, we are going to use a TLS connection or the SSL, we can say. And second thing, we need to pass on the username and password. And for any type of connection, there must be a type of retry mechanism, or we can say back-off logic with jitter, and there is a connection timeout, or the timeouts is required. So let's start it one by one. So first of all, we will just search here for the cluster only. Because we are interested in a cluster, we configure the cluster. So here is the that section. So this is the way how we can configure the Node.js or the snippets of the code to connect to the cluster. New Redis.cluster, we need to define the port and the host. We are ready with the port and the host. We also need to define the username and password. If you just scroll down here, maybe here is the option for username and password. Yes, so here is the option for Redis options password. If you want more about this password, I just take one bookmark here. So this is the official documentation or the official GitHub page for the Redis. Client configuration.md, we get all the options available for that for configuring the cluster on client side. So we need to pass on the username, password. So this here we have this requirement. We need to pass on username and password. So this is our basic structure for the cluster. New Redis.cluster. Okay. Our EC2 instance gets successfully launched or started. I will connect EC2 instance by using the session manager. So just click on connect session manager. Refresh. Connect. I already created snippets of the code for connecting to the Redis. So I will rename it as a Redis 2. And we are going to create another file for the as a Redis or the Redis.js. So let me become root here. Sudo su. So we are going to use the application 2. In that application 2, I already have that Redis.js. So I will rename it okay. Now we have a Redis2.js. So if you know, we are ready with our RDS code snippets. We are ready to retrieve the secret by using the secret.js, and we have also the backup.js for implementing the backup logic with jitter. If you don't know about the backup logic with jitter, just go through my previous video, you will get to know. Now we are going to create one JS file for the Redis. So we Redis.js. So as we do in MySQL snippets, we are also going to create here a function for creating the connection. So this is nothing but a synchronous function. We can say it's for the connection. And one more important thing about the, I want to tell you about the Redis, because Redis internally by default contain the back-off logic with jitter. So there is no need to implement a back-off logic with jitter or the logic of the code which we created, because our Redis will take care it internally. We just need to mention the retries or the milliseconds delay between the retries. And second most important thing is that the error handling in IO Redis cannot be get catched by the try catch block. I tried in my previous practice session, but any error thrown by the IO Redis cannot be get catched by the try catch block. So this is the main reason we are not going to use a try catch wrapper here. Just like MySQL, we just mentioned the try catch wrapper in the try block or the try execution context. We try to execute all the connection code. So here we are just going to create the cluster directly. So constant cluster. I will explain the retry mechanism. It's actually new Redis. Okay, let me just pause. Okay, let's cross check the syntax. It's a new Redis.cluster. It accepts two type of arguments. One is for the one is the array which contains a number of nodes, and second is the options. So where is that? Yes. Okay. So it's a new Redis.cluster. So R is a capital here. New Redis.cluster. What it accept? It accepts two arguments. One is array and second contains options. So this is our basic syntax. So we need to define here our host and the port. For mentioning host, we just need to, okay, first of all, we are going to mention the port, which is 6379. And what is the host in our case? In our case, host is nothing but our the configuration endpoint. Because if you remember, we selected here a cluster mode enabled. If you just click on that, there will be one, this is the shard 3, this is the shard 2, or this is a, we can say a shard 1. So each shard contain three types of node. One is a writer node and remaining two is a reader nodes. So there is only one endpoint, which is a configuration endpoint. In case of AWS, there is no need to manage the cluster discovery manually, because it will take care internally by the AWS. We just need to define the endpoint here. So we are going to define the endpoint here. So this is our endpoint. Now, what type of options we want to mention here? As we discussed, we have username also and we have password also. So we need to define the username and password. But how we can get the username and password? For getting username and password, we need to import the secret file. So import, maybe the it's actually get secret. Okay, let me cross check it. Vim rds.js. We actually imported it. Yes, it's const get secret required secret.js. We just need to pass on the ARN of the secret. Then it will get then it return the username and the password automatically. Okay, we are going to call it as a pool. I just remember from the word pool, because Redis is actually I just research on the Google, because Redis is a single threaded. There is a lot of documentation available. There is no need to create a pool for the Redis cluster or the Redis, because it executed one command at a time. So there is no need to make a pool of a connection. But when I asked to the ChatGPT and Open Meta AI, they suggest it's better to create a pool for connections. But if I read the documentation of Redis, there is not any option related for the making of a pool or the max connections, or we can say here is also not any option for related to the max connections. If you just go through all the options here, and if you just ask to the ChatGPT Meta AI, they provide one options, which is a max connection, and it worked. So we are going to use that options. support 6379. We have a host also. Now we want to define the username and the password. So first of all, where we can get the username and password? We can get the username and password by using this get secret command. So what will it does? There is a one variable which is a constant. It will going to call the get secret. And in that get secret, we pass on the ARN of our secret. So this is a new secret because it's as we discussed in our architecture, we are going to, okay, let me show you the architecture here. As we discussed in our architecture, we are going to retrieve the username and password in the secret manager. We are not going to hardcode it or storing it in the environment variables. We are going to retrieve it from the secret manager. Then we can access this Redis by using a IO Redis library. So we need to define here credentials, ARN of our secret. So how the username is username will be get here. So this is the const username equal to creds.username. Why this U is capital here? Let me show you that also. Because if you remember over, if you just click on retrieve secret value, here is the secret key is a capital username. So we need to define the capital U and the capital password. So it's a constant password equal to credential.password. Now simply we need to pass on the username and password here. So what is the syntax? Cross check it. It's a small username and a password. It's a username stored in the username, and this is our password stored in a password. So only these two options we are going to provide in the cluster configuration. No, we are also want encrypted connection between the client and our Redis. So what is the option for creating the encrypted connections? If you just scroll down here, we get an option here for the TLS connections. NAT mapping, by the way, is actually for accessing the Redis outside the AWS network. So read this section. AWS Elastic Cache for Redis support TLS encryption. AWS. If you use this, you may encounter errors with invalid certificate. To resolve this issue, construct the cluster with a DNS lookup option as follows. So we need to define this option also. By the way, it's actually contained in the Redis options username and password. Yes, it's actually contained in the Redis options. So we need to define here a Redis option. It's actually a Redis options. Okay, let me copy it syntax. So this is our Redis options. Okay, in Redis options we need to pass on the username and password, because I just check here in the documentation of IO Redis. So we need to define one more option here, which is nothing but the TLS for encrypting the connection. Remember, this actually contained in the Redis options. So we need to pass on here and to overcome from the certificate error, we need to define the DNS lookup here. So just copy that and paste it here. If you want to know in depth what is the DNS lookup and what is this syntax, again you can do OpenAI or a Meta. Now we are ready. What we passed? We passed port name, we passed port number, host name, DNS lookup for encrypting the connection, and Redis option for username and the password. And we try to get a password from the secret manager and trying to connect with the cluster. Now, more options is provided by the Redis, because as I explained you earlier, if we want to make a connection with any kind of database or Redis, there must be a connection timeout and a retry mechanism. So let's talk about the retry mechanism. Because there is no need to implement a backoff logic with jitter, it by default provided by the Redis. Let me show you that also. So this is the default code provided by the Redis. We can define the over delay here to implement the backoff logic with jitter. If you just scroll up, we can get there is a one code for retries. Okay, so this is nothing but a retry strategy. We need to just copy it and paste it. So there is no need to implement explicit logic related for the retry mechanism. We can define the retry mechanism here. If you want to change the delay between the retries, we can define the delays. There will be no issue. One more thing about the retries, let me show you that. Just read that content. By default, IO Redis will try to reconnect when the connection to the Redis lost, except when the connection is closed manually. Which means that it will try to reconnect again and again without any interruption till the connection gets succeeded. And if you want to implement such logic that after 6 retries the loop or the retries will be get stopped, then we need to define that logic manually. Then we can implement try catch block. In that try catch block we can define the counter. If the counter is equal to number of retries, then this reconnect will be get stopped. This logic we can implement, but for now we are not going to implement this backoff logic with jitter because it's by default get handled by the IO Redis. If you just pass on the number here in the times, it will give you error because it's a inbuilt function provided by the IO Redis. Okay, so now we are ready with the retry strategy, which will act as a backoff logic with jitter. Now, what about the timeouts? So let's get back. Okay, I will just do the Google here. Timeout in IO Redis. IO Redis connection timeout. So we will get that documentation link maybe. Okay, this is not. Command timeout. Okay, no issue. I will try to search in the official official documentation of IO Redis instead of in the GitHub. Okay, let me open that GitHub page also. I actually found out that isolated execution. There is actually a timeout provided by the IO Redis. Okay. Actually, there is a two type of timeouts provided by IO Redis. One is for the command timeout and one is for the connection timeout. Connection timeout is nothing but the we can say it's kind of a borrowed timeout which we seen in the RDS proxy. Okay, let me open that because we need to cross check. So these all are the options which we can define here. Enable offline queue, scale Redis. So we need to define the scale Redis here. Scale Redis is nothing but it can access the data from the reader instance. Scale reads, it's a scale reads and is equal to slave. If you not define the scale reads equal to slave, it will try to get the data from the writer instance or the writer node only. So we need to define that option also. I will just copy it and paste it there. Okay. If you just see here, there is only the option for the slot refresh timeout and the slot refresh interval. There is not any option for the connection timeout or the command timeout. There is actually an option for the retries delay on failover, retry delay on cluster down, retry delay on try again. We can define number of timeouts or the number of retries or the delay between the retries by using these options. We can also define the maximum retries for that specific command. So as we see in our MySQL code snippets, we implement the backoff logic with jitter separate for the connection and separate for executing the query. So here there is no need to implement the separate logic for implementing the backoff logic with jitter for executing the query, because inbuilt there is a one option which is called as a retry number of retries or the max retries for executing the command. And the delay, we can define the delay here: retry delay on failover, retry delay on cluster down, retry delay on try again, retry delay on moved on, retry delay on moved. So let me just show you that options. Where is that options? Okay, where is that options? Isolated execution AMD. No, that is not available in the isolated execution AMD actually. Examples maybe. No, there is not also any available. By the way, you can handle the error by like this only. We can define console.log. It will use a one callback function. It's a basic syntax for the Node.js. We can handle this type of errors, or we can use a asynchronous function, and this error can be caught by using a try-catch block. Just like MySQL, when we are going to execute our asynchronous function. Where is that isolated execution blocking commands? Yeah, one more thing about the blocking command is that because Redis is a single threaded, and if any user try to access all the keys contained in the Redis, then it will be block the CPU or lock the CPU. To overcome that, we can define the blocking commands in Redis also. So if you want more information, just go to again the documentation. I just got the information by just reading it, but I don't know about how to configure the blocking commands. But if you want, you can configure the blocking commands. Okay, clustering.md, timeouts, maximum command executions, socket.connect timeout. Okay, so might be this is the option which I am looking for, socket.connect timeout. It's just like a borrowed timeout which we said in the RDS proxy. The client will wait for that particular time till the connection get available in the connection pool. If all connections get used, if all connections get used by the elastic cache. And there is another option for connection command timeout actually, or the execution timeout. Let me isolation pool options. Okay, no worries. We are going to define that options on. Let me open my old file, redis2.js. Okay, so here is the options. We have retry strategy, we have DNS lookups. So this is the connection timeout. We have to explain. This is a max retries per request and command timeout. Connection timeout is nothing but like a client will wait for that timeout only to get a connection available from IO Redis. Maximum retries per request, which means the command will execute only the 2 times. Command timeout. If there is consider if there is a large number of data. Consider if there is a time required for executing the command, then we can define the command timeout. So I will just copy the all content or the all remaining options. Beam Redis.js insert mode. So this is my remaining options now. Connect timeout, max retries per request, and command timeout. And let me show you that for creating the connection pool also. If I open my GitHub here, GitHub account, projects cloud, connection pool. So Redis.js. I just mentioned one option is provided by OpenAI. I don't know where that option get can. It is the max connections. So this acts as a pool only, and there is not any type of error get thrown by this IO Redis library. So I will copy that also and paste it here. Because when in first time when I created this application, I got this option by asking to OpenAI or Meta AI. Okay, no worries. If you find out that option for maximum connections and connect command timeout, please let me know. Max connections 20, because I go to the GitHub page also, but I didn't find out that option, max connections and command timeout. But at afternoon I found out I just found out that option. Okay, it's an examples, maybe the examples, but examples related to the timeout only I want. Check connection status. No, this only the console.log. Stream producers. Okay, no worries. I will try to. Okay, let me try one more time here. Connection pool IO Redis. Connection pooling issues. It's actually for the 2015. We don't, and it's actually closed. I read this whole conversation. They are just saying that they are using a single threaded minimum maximum auto start. Yeah, and this is the another approach. If you want to make a pool, we can go through by using a generic pool. We can create a generic pool which is a inbuilt provided by the IO npm, or we can install that package for the creation of the pool. Then we can use the generic pool. This is another option which is also suggested by the OpenAI. IO Redis connection pool, and this is the another package for making the connection pool. New Redis pool, but I don't know it's available for the cluster or not. It's executing the finally block just like we did in the MySQL. If we just press the Ctrl C, it will end up the or closes all the terminate all the pools. But before trying to use that such packages, just notice here it's actually last published 5 years ago, and its weekly download is only 763. So might be this is not a good idea to implement or get the use of this package in our IO Redis. So this is the second reason why I just avoid by using this pool option also, because it is last published at 5 years ago. Okay, let's open that home page of a GitHub. Five stars to watching, 2 Fox only, and it's actually maintained at the 5 years and 6 years ago. Okay, no issues. Okay, till now I didn't get any options for creating the connection pool. But if I ask OpenAI, I just get that option, which is like the max connections. I don't know where the OpenAI get that option from. So no worries, we are going to implement four options here, which is a connection timeout, just like a borrowed timeout, max retries per request. If there is any error while executing the query, there will be we can define the number of retries, just like we implemented the back of logic with jitter for executing the query. Command timeout. So this is the timeout we can define for each command, and maximum connections. So these two options, because of these two options, max retries per request and the command timeout, there is no need to implement the back of logic with jitter. And command connect timeout, this is just like a borrowed timeout. And this retry strategy, this is the second reason why we are not going to execute the or implement the back of logic with jitter while making the cluster. Clear? Now we are ready with our asynchronous function for the pool. So what we are going to do, after everything seems fine, we are going to return that pool. It's a pool or it's a cluster? It's a cluster, and our function name is a pool. Now we are going to create another function, asynchronous function. It's a query. What that function? Okay, if you want to, we can implement a back of logic with jitter for executing the query. Okay, I will create here one cluster by calling the pool. So it will return a promise. And if this cluster or the connection is available, what we are going to do, we are going to use a constant data equal to cluster.get. We are going to set one value to the cluster. So what is the value? It's a foo. It's a key and it's our value. So we are going to return that data. If all seems okay, it will return the OK statement to the query. So this is our asynchronous function. And what if there is any error by executing the query? So for that, we can now call our back of logic with jitter actually. If you want to implement back of logic with jitter for the number of retries for the query, it's actually defined while making of the cluster max retries per request. But it's actually available for the cluster. If you want to explicitly provide the back of logic with jitter, we can also provide that. So let me show you how we can do that. So this is nothing but our asynchronous function, and it's type of arrow function. So we are going to use const data, and we are going to call the back of logic. It's a back of logic, and we are going to pass the reference of the function. So this is my reference of the function, and we are going to pass the number of retries. So this is the number of retries, and we are going to use the console.log data. So let me cross check my syntax. So I will go to the vim rds.js, which we created earlier. So this is the back of logic, which we implemented in the backup.js, and this is the way. Yeah, it's returning the promise, so that we need to it handle it by using a try catch block. I just forget that. So again, vim redis.js. So let's first of all import that package or import that code snippet back of logic. So this is the back of logic, same thing. We are going to use a try catch wrapper here. If everything finds, it will going to give a data here. If you don't know how we implement a back of logic, again saw my previous video. In that video, I just explained all the things about the back of logic and how it is going to execute. It will give console.log error. If you don't want to use a try catch block, there is another way also, which I told you earlier. We can, because the query is written a callback function, we can use a callback option also. So console.log error. So let's try to execute our file. Node redis.js. Okay, we got a syntax error. Might be there is not any. Yes. Port 6379. Okay, let me cross check it. What is the syntax error? Unaccepted token. Okay. Okay. We need to provide the one we need to pass it as an object. It's actually an array, and in that array we need to pass it as an object. Okay, now let's try to execute the snippet. Node redis.js. Okay, MS is not defined. Okay, MS is not defined, which means actually it's talking about this milliseconds. Back of logic, MS is not defined. Okay, so let's open the back of logic. Okay, it's actually back off. Let me cross check the parameters which we need to implement. Copy and paste it. So we need to define one function here, pass on the function reference, and we need to pass on the MS. Okay, so it's not actually a MS, it's actually a connection MS. So we need to give connection underscore MS. If you want to copy that this syntax, we can copy that syntax also for creating the back of logic with jitter. We can copy that syntax and we can paste that syntax here. Yes, retry strategy, so that there is no any execution of the same number. But by the way, it will get handled by the IO Redis automatically. Now let's try to execute node redis.js. Redis is not defined. Okay, let me cross check the file. Redis is not defined. Beam redis.js. Yes, we have that file. We executed the asynchronous function. We call the backoff logic. In that logic, we are passing the query. And we try to return the pool here. Okay, let me open my second file here. redis2.js. Okay, we also try to we also forget to wrap this query by using a try catch wrapper. So we need to implement that. Okay, so let's back to our query. Beam redis.js. Redis is not defined. Okay, that's interesting. Redis is not defined. So first of all, we are going to wrap this by using a try catch block. So if there is any error thrown by this asynchronous function, it get catched by the catch block. So this is our catch block. If there is error, it will throw the error. Throw error. And then finally, we are going to disconnect the cluster. So cluster.disconnect. So we need to define here one variable for cluster also. So let cluster. Okay. Asynchronous function await backoff logic with query. So there is no need for the cluster backoff logic. We implement the backoff logic for the query only. Now let's execute node redis.js. Cannot read properties of undefined. Reading connect. Okay. What about the secrets? Yes. Get secret. We have backoff logic. Cluster.disconnect. cluster disconnect. Await pool. We are calling the pool because we are returning the cluster here, and we are awaiting the pool. Await pool const data cluster.set foobar return data throw error cluster.disconnect disconnect. Cannot read properties of undefined. It's not undefined, it's actually defined. Beam redis2.js. Let's cross check it. Okay, here we also return the cluster here. Let cluster equal to await pool return result. Okay, if cluster, we need to define the cluster.disconnect. Okay, I will stop the video and I will check what is the issue here.